Good morning everybody, this is D. Vinay Kumar. Today we are discussing one more topic, asymmetric key algorithms. In the previous session we are discussing symmetric key algorithms. Now we are discussing about asymmetric. What is asymmetric key algorithm? In these algorithms, they are using two different keys. So public key as private key. Public key is shared by everyone, but private key is shared between those two parties who are sharing the data. Okay. So in the asymmetric key algorithm, we are maintaining two keys. That's important. Asymmetric algorithms, see here, what are the different basic concepts here? Public key, private key. So key pair, mathematical properties. Okay. So this algorithm mainly just pair of keys, one for encryption, public key, and one for decryption, private key. So public key is known by everyone, but private key is not owned by anyone, only two persons who are sharing the data. Okay. Examples of asymmetric algorithms, this is RSA, elliptic curve cryptography, Diffie-Hellman key exchange, digital signature algorithm, DSA. These are the four examples of asymmetric algorithms. First, RSA. This is also public key, one of the public key encryption system. It belongs to public key encryption system, which means it uses two different keys. Public key for encryption, private key for decryption. One key are using for encryption, another key are using for decryption. The security of RSA depending on the large composite numbers, making it completely secure. Based on the composite choosing composite numbers, the security of RSA should be dependent. Okay. So this is invented by Ron Rivest, Adi Shamir, Leonard Edelman. These are the founders of RSA algorithm. Okay. Key generation. So already we know. So in RSA we are using two keys. One key for public key, another key for private key. Public key is for encrypting messages, while private key is secret and used for decryption. Encryption, already we know. So already plain text is available to the power of the public exponent and taking models as a result with the public modules. Decryption, for raising the ciphertext. Here we are going for raising the plain text to the powers of public exponent. Here raising the ciphertext to the powers of the private exponent. Here plain text to the power of the public exponent. We are raising the ciphertext to the power of the private exponent. Here components are different. In encryption we are using public exponent. In decryption we are using private exponent. Okay. Security key length. What is the length of the RSA? RSA length should be 2048 bits or 2072 bits. These are the lengths of the key. Applications we are using here internet, including securing mail, web traffic. We are using this RSA. Digital signatures. RSA is used for create digital signatures also to verify the integrity of digital documents. Digital signatures generated by RSA help ensure the original and unaltered state of data. These are the applications of RSA. Challenges. So even though we are maintaining so many things in RSA, it is also attacked by the hackers easily. Okay. So key management. So vulnerable attacks are not implemented properly, such as padding, oracles, and side channel attacks. So it is not. It is a weakness. This is a weakness of the RSA. Padding, oracles, and side channel tracks. So key management security storage of private keys are critical for private keys. Next, the main challenge for this RSA is quantum computing threat. So what is the quantum computing? The advent of power quantum computers could potentially threaten RSA security by efficiently factoring large numbers. Even though we are generated for large numbers, this is can be easily hacked by known by the hackers. So by using different. So post quantum cryptography research aims to develop encryption methods that are secure against quantum attacks. So quantum attack is the main threat to the RSA. Quantum attack is the main threat to the RSA. Okay. Next, we can go for elliptic, second algorithm, elliptic curve cryptography. It is also one of the public key encryption technique that leverages the mathematics of the elliptic curves to provide security for various applications. Here are some points regarding ECC, elliptic curve cryptography. Here we are taking the curves defined by the equation y square equal x cube plus ax plus b. This curve has special properties that are suitable for cryptography operations. Efficiency and security. So ECC offers high level of security and relatively short key lengths compared to other public key crypto systems. Short key length leads to fast encryption decryption, making ECC more efficient, administrative for resource constrained and devices and applications. So here we are making short key lengths. By using short key lengths, so encryption should be faster, decryption also very fast. Okay. Key page generation. Here also we are maintaining same private key and public key. The security of ECC lies on the difficulty on solving elliptic curve discrete logarithm problem. What is the difficulty here? Security mainly depending on the difficulty of solving the elliptic curve discrete logarithm problem. Encryption. So the ECC encryption technique involves mathematical operations on points of the elliptic curve. The recipient public key also used to encrypt a message, and recipient private key used to decrypt it. Okay. So your receiver side also we can encrypt the message by using public key. Okay. Two sides, both sender and receiver they can encrypt the messages. Okay. Applications main should be ST, SSL, TLS for web security we are using mainly here. Securing messages, digital signatures, security key exchange like this. These are the applications of this elliptic curve cryptography. Key length should be 160 bits to 521 bits, with 250 bits being a proper choice. Okay. Resilience against quantum attacks is also to be more resistant to quantum computers, because RSA is attacked by quantum attacks, but it's somewhat better. It is against quantum attacks. So by using quantum attacks, the hacker cannot know the key of this elliptic curve cryptography. Challenges: proper implementation and parameter selection are crucial for ECC security. Safe key storage and management are essential to protect private keys. ECC is a part of various encryption standards, including those defined by the organizations like NIST and NSA. Okay. Next, third one, Diffie-Hellman key exchange. So now, up to now we are discussing regarding encryption, decryption, but here we are exchanging the key only. We are not doing any encryption, decryption. We are just exchanging the key. Key should be exchanged between two parties. Okay, that is Diffie key exchange. Okay, here see that is two parties to secure exchange the cryptographic keys for an untrusted communication channel. That is the main importance of this one. Okay. So here also public key cryptography is used two mathematically related keys, public key and private key. What is the key? How key exchange process? So suppose two persons are available, Ellis and Bob are available. They wish to establish a security key over an insecure channel. Both agree on public parameters, a large prime number and primitive root modulo PZ. PZ agree on both of these two parties. So they are applying two keys are available, two formulas, A equal to G power A mod P, B equal to G power B mod P. So both are private keys. Their A is calculated private key by using formula A equal to G power A mod P. Bob also calculated the formula B equal to G power B mod P. Key exchange. Ellis Bob exchange their public keys over the insecure channel, even though that is exchanging should be known and seen by everyone. There is no problem for Ellis Bob, because indirectly the secret key is indirectly available between Ellis and Bob. Using these public keys, they independently calculate the shared secret keys. They are calculated even though these are operations are known by anyone. There is no problem for Ellis and Bob. The shared secret key is follows. Again, they are calculating one more formulas: K equal to B power A mod P, K equal to A power B mod P. The result is the same shared secret key. So these K values are both are same. That is known by one Ellis and Bob. So what is the beauty of this algorithm? Even though the entire process is known by or seen by any person, so that the secret key is known by only Ellis and Bob only. The secret key is known by only Ellis and Bob. That is the beauty of this algorithm. Security. So the security are mainly depending on the discrete logarithm problem, which is computationally infeasible for large prime numbers and primitive roots. An eavesdropper listening to the public keys exchange Ellis Bob cannot easily compute the shared secret key without knowing A or B. Okay, what is A and B? So the hacker also cannot hack this secret key. So this is a perfect provides for forward secrecy, meaning that if an attacker gains access to the private keys of Ellis and Bob at a later time, it doesn't compromise the security of the previously exchanged messages, even though the hacker knows later time, not instant. Okay, that is the beauty of this algorithm. Applications. So here also web communications, VPNs we are using. is a fundamental building block for secure key exchange established secure applications. What different variants here? Elliptic curve Diffie element as well as finite field Diffie element, each with its own characteristics and security levels. These are the variants. Summary: this elliptic curve cryptography is a high efficiency and secure public key encryption technique that plays critical role, crucial role on digital communications of data. Here also same. Diffie element key exchange is also crucial cryptographic protocol that enables secure key exchange between parties over trusted channel. Also okay. Next, digital signature algorithm. Next, we are discussing one more algorithm here. The digital signature algorithm is a widely used asymmetric encryption method designed for generating verifying digital signatures. Today, just like signatures on the paper, some people are making digital signatures. Okay, just like computer-oriented signatures. Here are some key points regarding digital signature algorithm. DSA was developed by a National Security Agency, United States, and published as a US federal standard. It is widely used for ensuring data integrity, authenticity in various applications, including digital signatures for documents and software. So, for document safety, we are using digital signatures, and software safety also. Okay. So, the DSA is a publicly encrypted system, which means that uses pair of keys, private key as well as public key. Here also we are using both public and private key. Key pair generation, private key generation, a randomly chosen secret number, public key calculated as y equal to G4x mod p, where G is generator, P is a large prime number. So the parameters P and Q are commonly agreed upon values. So public key is known by anyone, but private key is secret. Signature generation. To send a message or document, the sender calculates a pair of values K, a random number generator for each signature, or calculated as G4K mod P mod Q. S calculated as K power minus 1 into H of message plus X into R mod Q. When H is as function, the signature is R comma S. Signature verification. To verify signature, we are calculating W using formula UL, U1, U2 and V, where V equals R, the signature is valid. So by using these formulas, we are calculating different values. Here finally, both V and R are same, then only signature should be valid. Security. Digital signature security mainly depending on the difficulty for solving discrete logarithmic problem, so especially modulo P. The choice of parameter PQ is crucial for security. D is not suitable for encrypting data. It is the primary user for signing and verifying digital signatures only. It is also not used for encrypting the data, only for signing and verifying digital signatures. Applications. How do we know? For web connections, software code signing for software distribution, this is used. It ensures data integrity and authenticity as well as non-repudiation. These are the security concepts of our system. Challenges. Proper key management, secure storage of private keys are crucial. They are crucial for DSA effectiveness. Care must be taken when choosing parameters to avoid weaknesses. Standards. The DSA is standardized by organizations like NIST and variations like EEC, DCSA and also widely used. Operations asymmetric algorithms. So we are using for key pair generation, encryption, decryption, digital signatures. We are using different operations of asymmetric algorithms. Key pair generation is nothing but public and private key. Encryption already we know, decryption already we know, digital signatures. So to recognize a document, we are using digital signature. That is the authorized person signature or other person. That is known by digital signatures. Application service, secure communication, digital signatures, secure email, key exchange, authentication. These are the all applications of the asymmetric algorithms. Summary. Here also we are discussing two things: electric curve cryptography as well as digital signatures algorithm. Electric curve cryptography we use a public key generation. So it is a very effective algorithm. It resistance to quantum attacks as well as broad applicable to make fundamental component of modern cryptography. Digital signatures also same point of view. It is also very good algorithm. So, but it is only for recognizing digital signatures only, not for encryption. Okay. Security considerations. While asymmetric is powerful tools for security, they require careful. So everywhere the point should be same. Careful key management and protection of private keys should be very important. If private key is known by other person, automatically there is no use of these algorithms. Initially, the strength of these algorithms relies on size of the keys used. with longer keys providing stronger security. Key more size means so security also strong. Conclusion. What is the conclusion here? Asymmetric algorithms play a crucial role in securing data communication, digital signatures, as well as authentication in today's digital world. Understanding these principles, algorithms, we are building secure systems and maintaining our data privacy and integrity. Proper key management and choice of the appropriate algorithms are fundamental in achieving robust security. Thank you.